This class will be about training methods for improving horizontal force production in soccer. And basically, the objective of the class will be first to give you an introduction and to define the main concepts. Then we will talk a lot about the concept of effectiveness of force production in sprinting. And we will talk specifically about the role of hip extensors muscles and the ankle foot strength in providing effectiveness. Then the applications will all be about some exercises to train the players to improve this effectiveness of horizontal force production. We will talk about how to increase the hip extensor power. We will talk about how to improve the horizontal orientation of the force. And we will discuss some exercises to mix both ankle stiffness and forward orientation. Let's go. So basically, when you talk about sprinting in humans, you talk about a challenge because we are not made for sprinting. We are not made for acceleration. We are made for endurance. So basically, if you want your football players to improve their acceleration, you have to face their nature. But we can do it. If you look at this picture here, it's a bit old, but it tells you that in the animal kingdom, we are not very good sprinters. For example, the fastest human sprinter, Usain Bolt, he's only able to run at 45 kilometers per hour. This is the same as a wild rabbit, and this is the same as an elephant. So basically, when you train football players, always remember you train something that they are not made for. But it's a challenge, and it's the aim of a good coach, right? So you need to remember that in team sport, for example, in football, acceleration is the key. Because in many situations in the game, you have not enough time and you have not enough distance to reach your maximum velocity. But taking the ball, being first, cutting in is really about accelerating. So improving velocity from zero or from a running position. So that's what we are going to talk about. You always have to remember that the laws of motion are the laws of Newton, and the main law of motion, we call that the law of dynamics, tells that to accelerate, you need to produce some force. Newton said the change in velocity is proportional to the force. So you would say, okay, to accelerate a lot, I just need to produce a lot of force. But this is wrong, because the second part of the law of dynamics says to accelerate in a given direction means to orient the force in that direction. So to tell things simply, if I want to accelerate forward, I need to produce some force and I need to orient the force forward. If I push the ground vertically, I will not accelerate my body forward. This is pretty simple to understand, but it has major consequences on the training. Look at these animals. These animals run super fast because they are able to produce some force, okay, but also because they are able to transmit the force to the ground, because your body moves because you push onto the ground. In a soccer or in a football context, your body moves because you're pushing on the pitch. Look at this picture in details. If you see the dog and if you see the girl, basically their movement will be generated by the force output they can produce onto the ground. What is the advantage of the dog in this situation? As you can see, the orientation of the force for the dog is much more horizontal. The orientation of the force for the girl is much more vertical. So it means that even if they produce the same force, the dog will accelerate more because of this orientation. If you take that to the football context, you understand that to accelerate forward, you need to produce force, yes, but you also need to have an effective orientation onto the ground. So we'll go back to some research that we did. This paper was published in 2011, and we proposed the concept of the technical ability of force application. So as you see on this picture, how the force orientation will be related to the sprint acceleration performance. The main concept here is what we call the ratio of force. So basically we will define the concept, we will see what muscles are involved, and then what training exercise you can use. The concept is very simple. It's a ratio. So it means it's a percentage between the horizontal component of the force and the total force output. So for example, in this situation, if my body is able to produce the total force that you see, it's the black vector, the orientation of this vector, the angle, will immediately dictate the horizontal component. So in this example, I have a ratio of force of 35%. What you need to remember is that if I orient my push more horizontally, for the same force, I will accelerate more. The second concept is that when some sprinters or when some football players accelerate, their body has a position that goes from horizontal to upright. This is something we cannot avoid. It is systematic. So for example, in this picture, it's a sprint on a treadmill. You have the step number 1. You see the athlete is pushing horizontally. And at step number 6, the athlete is pushing a bit more vertically. So basically, what happens when you accelerate is that step after step, the ratio of force decreases. It means step after step, your push is more and more vertical. And what you see in this graph is that the decrease in the ratio of force, so what we call the DRF, decrease in the ratio of force, the DRF is something that is linear. So here you have the ratio of force for all the steps of an acceleration. So 40% is the first step, so it means that the athlete is very well pushing forward, but then the ratio of force decreases. It means that step after step, the athlete cannot push forward as before. So basically what we proposed is that the slope of this, so the rate of decrease in the ratio of force, is a good index of the effectiveness of force application. To summarize, if I have a very fast decrease in the ratio of force, I am not very effective, because it means that during my acceleration, I will very quickly get upright and I will not push horizontally anymore. On the opposite, if I have a very slow rate of decrease of the ratio of force, I am very efficient. So it means that my acceleration will be longer and better. To give you some numbers, because we have numbers on many different people, elite sprinters are able to lose 4% of effectiveness for every new meter per second during their acceleration. So they have a very low decrease in the ratio of force. But the non-specialists have, for example, minus 12%. So it means they lose 12% of effectiveness at every new meter per second. So here you need to understand that if I want to have a better acceleration, I need to maintain my ratio of force, or I need to limit the decrease in the ratio of force as much as possible. So now the question is, how is this related to acceleration performance? To answer that question, we did a study. We took some athletes, some football players, and 2 sprinters. We asked them to do a sprint on the treadmill so we can measure their ratio of force. And just before or just after, we went to the track and we did a sprint test. So on the treadmill, we quantify how much force they can produce and their effectiveness, how effectively they transmit that force. This will be the DRF index. Then we basically check who is a good sprinter and who is not a good sprinter. We have, for example, the distance in 4 seconds, which is an index of acceleration capability. So let's take a look at the results. Here in this table, you have some correlation data. Basically, here you have a positive correlation between the index of force application, the DRF, the horizontal force output in units of body weight, and the horizontal power output. It is correlated with the 100-meter performance, and it is correlated with the 4-second distance, which is the acceleration performance. So the first result here is that, yes, the athletes with a better effectiveness, with more horizontal force on the treadmill, are the best athletes on the track. The other interesting result here is that we don't have a clear correlation between the vertical force on the treadmill and performance, and between the total force on the treadmill and performance. So the conclusion of this first study was that what's important in sprinting is the horizontal force production and not much the total force production. So it's not who is the strongest guy. It is who is the strongest guy in the horizontal direction. Furthermore, the total force was not correlated with the DRF. What does that mean? It means that the physical capability of force production, my force capability, is not related to my technical ability. So it means that these are two separate capabilities that I should monitor and that I should train. I will give you a typical example here that is very, very illustrating. You have two athletes. They do a sprint on the treadmill, and as you can see on this graph, we have the ratio of force decrease with increasing velocity. Okay? One athlete is a long jumper, is a good sprinter, and one athlete is not doing track and field, is a cyclist. What do you see? One has a very good DRF, decrease in the ratio of force. His number is minus 5%. And the other one has a very, let's say, weak DRF. His index is minus 8%. So if you understand, one will maintain the ratio of force, but the other one will lose the ratio of force. Now let's take a look at the characteristics of these two guys. They have the same body mass. They have about the same body fat, so it means they have about the same muscle mass. In addition, their total force is about the same. So it means during a 6-second sprint on the treadmill, they are able to push the same amount of total force. If you want to summarize, these two guys have the same motor. They have the same force capability. But if you look at their DRF, one is minus 5%, it's pretty good. The other one is minus 8%. It is not good. Now let's take a look at their performance. So it was a 100-meter test with running shoes and no starting blocks. One is 11.9 seconds. The other one is almost 14 seconds. And if you take a look at the distance in 4 seconds, it's, for example, you have a football ball to catch and be first. In 4 seconds, there is 3 meters of difference between the two players. So if these two players are an opponent and a defender on a pitch, there will be a clear difference. But they have the same body mass and they have the same force output. So you need to understand that what's important is not much the force, it is how you apply the force. So the conclusion of the study here was the effectiveness of force application is more important than the total force produced. It has a major consequence on training because it means you should train for force production, okay, but you should also train for a good application of that force. One limitation of the study is that the population we tested did not include some good sprinters. Okay, the best guy was 10.9 seconds. So it's not a very good acceleration. It is okay, but it's not perfect. So we wanted to do a study on elite sprinters to see if the best guys had also these characteristics. So this is what we did in 2012. And we were lucky to study a French guy named Christophe Lemaitre and to have a case study. So just for you to remember, Christophe Lemaitre was a very good young sprinter. And you have to consider that he was able to run under 10 seconds, so it's a very good level of sprint, with this body and without doing any strength work. He was 9.92 in 2011, and at that time, he did no heavy strength training. No gym, no squat, no press, nothing heavy. So the question for a researcher is, how can he do that? How can you accelerate a lot? How can you run that fast without doing strength work? The second question is, as you can see from the pictures, he doesn't have a lot of muscles. So he's not bulky, he doesn't have hypertrophy, but he can run less than 10 seconds. And if you want to have a football player that is fast, less than 10 seconds is very good. So we had a research, and basically what we did is that we tested this athlete at the lab, and our hypothesis was, well, if he doesn't have a lot of force, maybe he has a very, very, very good force application. So that's what we did. In a second study, so we tested exactly the same. We tested the guys and the athletes at the laboratory on the treadmill, and just after or just before, we did a 100-meter test. As you see on the picture here, we also tested this very fast player. So we compared the world-class sprinter. We compared him to very good sprinters in France, 10.3, 10.6 seconds. This is quite fast. And we also compared them to physical education students, football players, rugby players, non-sprinters. Okay? So I will show you the results of this study. So in this table, it's very easy to understand. The first column is the world-class sprinters data. The second column is the good sprinters, so national level, and the percent of difference. And the last column is the non-specialists. Focus on these two first lines. The horizontal force output was higher in Christophe Lemaitre than in the good sprinters, and much higher than in the non-specialists. And the DRF index was the best in Christophe Lemaitre. So he has a minus 4% DRF compared to the minus 6% of the good sprinters and compared to the minus 8% of the non-specialists. So this is a major difference. The very interesting point is that the total force output, so it means the total force that was applied onto the treadmill during 6 seconds, was very close between the world-class sprinter, the national level guys, and the laboratory guys. I have a friend who is able to push more on the treadmill than Christophe Lemaitre. But my friend is not fast. You know why? Very simple. Because my friend has a very vertically oriented push and is not very effective, contrary to Christophe Lemaitre. So basically this study is confirming the previous results, and I think, and now everybody agrees in the scientific community, that the resultant force should be applied very horizontally for a good acceleration performance. Remember, we only talk about acceleration. We are not focusing on the maximum speed phase of a sprint, because in soccer, maximum speed doesn't occur very often. Now, this is the model. The model of a good acceleration in track and field or in football is producing force and transmitting the force to the ground. If you produce a lot of force, but you don't apply it correctly, it is useless. If your training develops your force capability, but you forget to develop the transmission, maybe you will lose time. Last point, you need to do all of this at a very high movement rate. It means soccer is not athletics, but on a football field, people are moving very fast. So you need to remember, you need to be strong and also fast. Now, the big question in training is, how can I train my effectiveness? How can I do to improve my horizontal force capability? This is what we addressed, and we have two hypotheses. We think that to push horizontally in sprinting, you need two things. You need to work on your hip extensors, these muscles here, the muscles that kick your leg backwards, so it's the gluteus and the hamstrings. And you also need to have a very good foot and ankle strength and stiffness. Why? Because think of it. When you sprint on a football pitch, the force is produced, but the force is transmitted at your foot. So it means if you have a strong body and if you produce some force, but your foot is not strong, you will lose a lot of energy. So why did we focus on hip extensors? If you see the scientific literature, you see some studies that show that when we run faster on a treadmill, for example, the activity of the gluteus muscles and the activity of the hamstring muscles increases. Okay? But the big limitation of these studies is that it was a constant speed science. So basically we asked some people to run slow, then intermediate, then fast. They run at a constant speed and we measure the activity. What is the limitation? Well, the limitation is that they don't accelerate. So it is not a real acceleration context. Still, if you look at this graph, you see here the ratio of force decreasing between Christophe Lemaitre, the top-level sprinter, the national sprinters that we've tested, and the non-sprinters. What do you observe? Well, you see that the decrease in the ratio of force is better in Lemaitre because of what happens at high velocity. If you take a look at the left part of the graph, at low velocity, the effectiveness, the ratio of force of Lemaitre is about the same as the other guys. But when the velocity is high, there is a big difference between Lemaitre, the non-sprinters, and the good sprinters. What does that mean? It means that the big difference in the horizontal force happens at high velocity. Now, the question is how to produce a high horizontal force on the ground when your body is running at high velocity, because that's the key. When your body is running at high velocity, your position is upright. It means you cannot use your body orientation to push horizontally, so you have to produce some backward force on the ground with your body like this. It's what happens on the soccer pitch always. So football players always start sprinting with their body like this. So functionally, as you can see in this picture, the muscles that you use are the hip extensors. Because if you extend the hip on the ground, you will produce some horizontal force and you will accelerate forward. Okay? So this is exactly what happens in this situation. If this player wants to accelerate, he pushes on the ground with two major muscle groups, the hip extensors, and look at his foot. The foot is pushing the ground. So that's why in our model, you need to work on these two muscle groups.